All right, so let's actually go through this integral using integration by parts and going through kind of all the nuts and bolts to kind of acquaint ourselves with the steps that are going to be necessary. So remember, if we're looking at this integral of 7x times cosine of x dx, we originally saw, well, there's two functions sitting there. There's that 7x piece and that cosine of x piece, which we have the product of two functions, so we're immediately thinking this could be u substitution, this could be integration by parts. However, since neither of these functions looks like the derivative of the other, or piece looks like the derivative of the other, we're not thinking u substitution here. We're thinking integration by parts. So integration by parts, we get to define two things from the get-go. We define a piece to be equal to du and another piece equal to dv. And the u piece we're going to differentiate, that dv piece we're going to integrate. So what do we call u? What do we call dv? In this case, I'm going to call u this 7x piece, and I'm going to call dv that cosine of x. And you might be wondering how I made that decision. So let's get into it. Well, when we differentiate that u piece, so say take du dx, we get that the derivative of 7x is well just equal to 7. But what we want to do is solve for du. So we get du is equal to 7 dx. And what we actually see is by calling that 7xu, when we differentiated it, it really reduced the complexity in x. We went from an x to the first to an x to the 0, or just no x's there at all. So I'm thinking we call things u that we can reduce kind of the complexity in x sometimes. Whereas this dv piece, what we're going to do is integrate both pieces. So we get a v by itself. And while the integral or antiderivative of cosine is just equal to sine of x. And now in this case, for integration by parts, we don't actually need a plus c here. So at this junction, we have our u, we have our du, we have our dv, and we have our v. So we're ready to recombine all of those four characters I just mentioned using our integration by parts formula to give us an equivalent integral. So recombining, we have our formula for integration by parts, u times v minus the integral of v du. And our job is, well, just pop in what we found earlier. So remember, our u from up above was equal to 7x. So we just place a 7x wherever there's a u in this formula. Our v was equal to sine of x. So we just pop that in. Then we have minus the integral of v, which we saw was sine of x. And then finally, we multiply by our du, which now hopefully you're seeing why we need to connect that dx there for that differential. So we have that du is equal to 7 dx. And at this stage, we've recombined our integration by parts characters using the integration by parts formula. So we have an equivalent form of that original integral that we had up above. Now, mind you, nothing is free here. We reduce that integral into this new thing down here. But if we look, we still have one piece that involves an integral. So as long as we can do that last integral, we've been successful here using integration by parts. So let's just go ahead and kind of finish off this problem. So this first piece is just 7x all times sine of x. Nothing changes there. This integral we get to do as well, minus the integral of 7 times sine of x dx. And again, as long as we can do that integral, we've completed our original integral using integration by parts. So just remembering, we can pull that 7 out in front of that integral if we wanted to, but the integral or the antiderivative of sine is a minus cosine. So this problem reduces to, we have 7x sine x from the beginning, we have a minus, and then we have a minus 7 times cosine of x, coming from the antiderivative of 7 sine x. But we're not done yet because we get to tack on a plus c. And the last very step we could do as well, we have this minus here, we have a minus there. So a minus minus just gives us a plus. So the final antiderivative here is 7x times sine x plus 7 times cosine of x plus c. And that's our final antiderivative using integration by parts.